What if the world's next oil field isn't on Earth at all? Not buried under oceans, not locked inside deserts, but orbiting silently high above our heads. Right now, a new kind of energy race is unfolding, one that doesn't rely on pipelines, refineries, or power plants. It lives in space. 36,000 kilometers above the surface, a new kind of infrastructure is quietly forming, one that could power the planet without burning a single drop of fuel. It doesn't depend on weather, borders, or time. It exists in the endless sunlight of space. For most of history, power meant oil, coal, and pipelines. But what happens when power itself becomes orbital, when energy floats above nations, beyond ownership, and outside the planet's reach? The answer isn't just about technology, it's about control. Because while engineers work to make it real, financiers and governments are already competing to own it. This is the story of the 3 trillion space grid, the invisible energy empire being built above our world. In early 2023, a small satellite launched from California quietly achieved something extraordinary. It was called MAPLE, short for Microwave Array for Power Transfer Low Orbit Experiment. It didn't carry astronauts or cameras. It carried a dream that had lingered for 50 years, to collect solar energy in orbit and beam it back to Earth. On a calm morning, researchers at Caltech confirmed what had once been science fiction. The satellite had successfully transmitted solar power wirelessly from orbit to a ground receiver. The amount of energy was small, just enough to light a few LEDs, but symbolically, it was monumental. For the first time, humans had proven that orbital solar power could reach Earth. Behind the scenes, that quiet moment signaled something much bigger, the dawn of a new energy economy, one that could eventually operate entirely outside the planet's surface. For decades, scientists have known that sunlight in space is 10 times stronger than what we receive on Earth. No clouds, no night, no atmosphere. In orbit, the sun never sets. A single square kilometer of panels could power an entire city. The problem wasn't the science, it was the cost. Launching such systems was once absurdly expensive. But in the last decade, everything changed. Launch prices have fallen by nearly 90% thanks to reusable rockets. Solar panels have become lighter, thinner, and more efficient. AI can control precision energy beams from orbit with accuracy measured in millimeters. The barriers that made space power impossible are crumbling one by one. And now the race is officially on. Japan's space agency, JAXA, has been developing its own orbital solar program for more than a decade. Their plan, vast solar arrays floating in geostationary orbit, beaming gigawatts of clean power to Earth. The first full-scale transmission test is scheduled around 2025. China, never one to be left behind, has built entire testing facilities in Chongqing to simulate orbital conditions. Their stated goal? Launch a fully operational solar power station by 2035, one that could deliver constant wireless energy from orbit. In the United States, private companies are quietly working alongside NASA and the Department of Defense on similar systems. It is easy to look at all this as a story of innovation, a new chapter in the march of clean energy. But it's much more than that. Because when something as vital as power leaves the planet, everything changes: economics, politics, even sovereignty. Already, some of the world's biggest financial players have noticed. The same trillion-dollar asset managers that control most of the global economy, BlackRock, Vanguard, and State Street, are quietly investing in the supply chain that will make the space grid possible. Aerospace manufacturing, rare earth mining, satellite infrastructure. To them, this isn't space exploration. It's future infrastructure. If you think this sounds familiar, it should. In the 20th century, control over oil pipelines defined global power. In the 21st, the same may be true for orbital energy networks. The companies and governments that build and finance them, just sell electricity. They all hold leverage over nations. Because when power flows from orbit, control flows with it. The potential market value of space-based solar energy is estimated to reach $3 trillion by 2040. That is not an exaggeration. It is a realistic projection based on global energy demand and infrastructure costs. For comparison, the entire oil industry today is worth about $4 trillion. In other words, this single idea could become one of the most valuable industries in human history. But there's a catch. Orbit, unlike Earth, has limits. Geostationary orbit, the sweet spot where satellites stay locked above a single location, is already crowded. Every new satellite requires an exact position and frequency clearance. Those positions are controlled by the International Telecommunication Union, and there are only so many left. That means orbital real estate, literal space in space, is becoming the next scarce resource. Governments are already negotiating for their share. Private companies are applying for long-term orbital slots years in advance. What was once limitless sky is quietly becoming the world's most valuable property. And here's the quiet alarm few are talking about. Once the orbit is full, there's no more sky left to claim. That single fact could change everything. Because whoever gets there first stays there. Ownership of those orbital coordinates could grant permanent control over the world's future energy supply. It is a race without a finish line, and the prize isn't tea, land, or oil. It's sunlight. Imagine the geopolitical implications. A country with orbital power stations could beam electricity directly to allies, or cut off adversaries without firing a single shot. They could export energy wirelessly, regulate access, or weaponize supply. Energy, once decentralized and earthbound, could become a tool of soft dominance, projected not through territory, but through orbit. Of course, public messaging won't sound like that. Nations will talk about sustainability, cooperation, and global benefit. But behind the scenes, this is an arms race dressed as a green revolution. Engineers will build solar panels, but politicians will draw borders around sunlight. The irony is striking. For the first time, humanity might achieve clean, limitless power, and immediately find a way to turn it into competition. Still, the promise is impossible to ignore. Constant power, no emissions, no dependence on oil states or coal fields. Every city on Earth powered by sunlight from orbit. It sounds utopian, and in a sense, it is. But history suggests that whoever builds the system first won't just share it. They'll monetize it, regulate it, and protect it like any other form of capital. And so, as nations and investors quietly assemble this new infrastructure, one truth becomes clear. The space grid isn't just a technological project. It's an economic migration, a shift of energy, money, and power from the ground to the sky. If the internet became humanity's nervous system, transmitting information, the space grid could become its circulatory system, transmitting energy itself. And once that happens, control will no longer belong to the engineers who launch it. It will belong to those who finance, regulate, and own it. The question isn't whether space-based energy will exist. It's who it will belong to when it does, because whoever claims the sunlight above may decide the fate of everyone below. The story of energy has always been the story of civilization itself. Every era has been defined by the resource it mastered and by those who controlled it. Coal powered the Industrial Revolution and built empires. Oil fueled the 20th century and shaped geopolitics. But as humanity turns its eyes upward toward orbit, the next chapter is being written quietly and faster than anyone expected. Space-based solar power isn't just another technological leap. It's a complete redefinition of energy itself. For the first time in history, power won't be bound to geography. It won't matter where sunlight falls or oil is buried. Energy will become mobile, captured in orbit and transmitted invisibly across continents. And once energy becomes mobile, ownership becomes abstract. This is where the story leaves science and enters finance, because every great infrastructure of history, railroads, cables, pipelines, began not as engineering marvels, but as financial bets. The space grid is no different. Trillions of dollars are quietly being positioned for it. The same institutions that financed the industrial age are now preparing for the orbital one. BlackRock, Vanguard, and State Street, the invisible engines behind global markets, already hold shares in nearly every company connected to this ecosystem. Aerospace manufacturers, launch providers, rare earth mining firms, and wireless energy specialists. To them, space-based energy isn't about saving the planet. It's about building the next asset class. Power from orbit will be securitized, insured, traded, turned into financial products that can be owned, leveraged, and sold. The sunlight above our heads will become an entry in a digital ledger. A Caltech researcher once said, "Space-based energy will be the first resource humanity owns without touching it." That single line captures the entire paradox of this age. The cleanest form of power may also become the most centralized. For now, everything looks cooperative. Scientists collaborating, governments signing joint declarations. But treaties and partnerships are temporary. History tells us that once a resource becomes profitable, sharing stops. That's already happening. China's National Space Administration has announced that its planned orbital solar stations will operate under Chinese jurisdiction, not as part of an international grid. The United States is pursuing its own commercial-led model through NASA and the Department of Defense, with private firms like Northrop Grumman and Blue Origin quietly testing power beaming systems. Europe and Japan have partnered to develop energy security from orbit. Everyone talks about sustainability. But behind the language of climate action is the same motive that driven every energy revolution before: control. And in orbit, control means something new. Geostationary space, the narrow belt where satellites remain fixed above Earth, is already crowded. There are only about 1,500 usable orbital slots available for permanent systems. Many are already occupied by communications and military satellites. If space-based energy takes off, demand for these slots will skyrocket. And once claimed, they can't easily be given back. As one aerospace engineer from JAXA put it, we're not just running out of land, we're running out of sky. That scarcity transforms orbit into real estate, an extraordinarily valuable real estate at that. In the coming decades, we may see orbital coordinates traded like oil fields or broadband frequencies. Entire financial markets could emerge around who owns which beam paths, which frequencies, and which segments of sunlight. For now, the public conversation remains technical. How to transmit energy safely, how to prevent atmospheric interference. But behind the scenes, the language is shifting from science to sovereignty, because when energy flows from orbit, it can also be stopped from orbit. Imagine a world where a country's power supply depends on an array of satellites owned by another nation, or even a corporation. One software command could dim the lights in another capital. One algorithmic glitch could disrupt an entire economy. The idea sounds extreme, yet it's built into the architecture of the system itself. That's why defense agencies are already involved. Power stations in orbit will need protection, not only from space debris, but from cyber attacks or intentional interference. Energy security will merge with national security. The space grid may look like a clean energy network, but in practice, it will function like an energy shield, guarded, monitored, and militarized. And still, it's hard not to be fascinated by what's possible. Imagine vast panels in orbit collecting sunlight 24 hours a day. Power beamed wirelessly to cities, electric aircraft, and entire industries. Desalination plants in Africa, data centers in Asia, all powered by the same constant stream of light. No pollution, no fuel, no dependence on oil. It's an awe-inspiring idea, a world where energy scarcity finally ends, but abundance for some can still mean dependence for others. The countries and corporations that build this system will own the transmission channels, and by extension, the flow of civilization itself. Developing nations might be able to purchase energy from orbit, but they'll never truly own it. The space grid could repeat the same colonial dynamic of the past, where those with the technology rent out power to those without it. Economists call this energy asymmetry, when access is global, but ownership is concentrated. In the age of orbital energy, that asymmetry could become permanent, because once the infrastructure is in place, no one can compete without billions in capital and orbital access. Who will be able to challenge that? The quiet answer is almost no one. As the grid expands, it could eventually tie every region to a single interconnected energy web. In that world, sovereignty may no longer mean independence, it may mean permission. If that sounds dystopian, consider this. We said the same thing about data 30 years ago. The internet promised decentralized freedom, and today, a few corporations control most of it. The space grid promises the same thing for energy. Will it follow the same path? For now, the technology is still experimental. The economics are speculative. But the momentum is unmistakable. Governments are investing. Private firms are testing prototypes. Venture funds are forming new categories called orbital infrastructure. It's all happening, just not publicly. If projections hold, the first commercial orbital solar station could beam gigawatts of power to Earth by the mid-2030s. By 2050, a global constellation could provide continuous energy to every continent. Some will call it the clean energy miracle. Others will call it the largest corporate privatization of power in history. Both might be true. And when that day comes, the light that powers your home may not come from your local grid or even your country. It will come from a machine you'll never see, silently orbiting above the clouds, owned by someone you'll never meet. For the first time in history, humanity will look up at the night sky and see its own infrastructure staring back, because the sky above us, once the symbol of freedom and exploration, will have become humanity's greatest machine and its most valuable asset. Every age is defined by who controls power. Coal-built industry, oil-built empires. Now, sunlight, captured in orbit, may build the next one, and the same truth will echo again. Whoever controls energy controls civilization.